Okay, basic reciprocal functions, y equals 1 over x. We evaluate the basic reciprocal function at every one of our standard x values, provided it's possible to do the evaluation and to get the exact result. So, when x is -2, 1 over x is clearly 1 over -2, which is -1/2. When x is -1, 1 divided by -1 is -1. X divided by -1/2 is -2. X divided by 0, you cannot divide by 0. We've talked about that elsewhere. This is forbidden. So we'll kind of cross it out. 1/2 gives us 2, 1 gives us 1, 2 gives us 1/2. So the domain of the basic reciprocal function consists of the x values -2, -1, -1/2, 0, 1/2, 1, and 2. The range consists of values that we have for our y, and we're going to list them from least to greatest. The least is -2, and then -1, -1/2. Might be a little hard to read. Okay, there are negative numbers, and then we have 1/2, 1, and 2 in increasing order. They don't have to be listed in increasing order, but it's much easier to comprehend what you're saying if we do have things in increasing order. Okay, a graph of our basic reciprocal function. We've got numbers from -2 to 2 because for all our basic functions, that's the domain of our 5 most basic functions. I've already subdivided this interval, subdividing half, taken the halfway point between 0 and 2 to get 1, halfway point between 0 and 1 to get 1/2. Do the same thing on this side. I get my -1, -1/2. Excuse me. Okay. Now we've got to go 2 units up. So let's see, 2 is going to be about here. We subdivide the interval from 0 to 2 to get 1. Then we subdivide that interval to get 1/2 because we know we're going to need a 1/2 because it's in our range. And then we go from 0 to -2, which would be down about here. And, you know, I always fail to have the foresight to label this on the right-hand side of the graph, so the graph doesn't run through my labeling. I have a problem up here too. I might escape it because I'm using a big scale. Okay, 0 to -2. I've got -1 here. And I did it again. I've got -1/2 here. I want my -1 there, not here. Okay. So we plot our points. -2, -1/2. Here's -2, here's -1/2. There's our point. -1, -1. There's -1 and -1. Horizontal and vertical lines come together here. -1/2, -2. That's why I didn't want my -2 down here. Then I get a point right here. Okay. Then 1/2, 2, 1/2, 2, 1, 1, and 2, 1/2. So there is our basic function. Now we can do, as we tend to do, the extended basic function, which runs from this point on a smooth curve down to this point, which I missed because my hand was in the way, including this point and this point. So we'll pretend this point is where it should have been. Okay, up here, we go from this point down through this point get to this point. We put a heavy dot on each of those points, and now we can see this much of the graph. We do not attempt to connect this point to this point, because if we did, our curve would go through the y-axis. If our curve went through the y-axis, then we'd have a value for x equals 0, and this function not defined when x equals 0. So we don't attempt to connect this point to this point. You might attempt to do that if you accidentally thought that 1 over 0 was 0, but that's not so, because 0 times 0 is not equal to 1. Okay, and it's wrong in another way too. If we want to negative 1/10, 1 divided by negative 1/10 would be negative 10. So if we were at negative 1/10, which is about here, we'd have to be 10 units down, about where the floor is. Okay? Or if we did 1/10 here, we'd have to go up 10 units here. And I can't reach so high. The ceiling gets in the way and stuff. Okay, so that's the extended basic function. And its domain is a set of x values that correspond to the curve. Okay? And you know what? I listed the domain here. I included 0. Okay, that's a very bad mistake. Unfortunately, when I get into a pattern, sometimes I'll continue without thinking. You want to be careful about that too. 0 is not in the domain. Okay, now, the domain of the extended basic exponential function, well, your x values just go from -2 to -1/2. The function stops here. You don't have any points on the extended basic function that go beyond this. No points between here and here. So there are no x values between -1/2 and 1/2. So the domain of this function is the interval -2 to -1/2. -2, 2 again. Okay, and that's this part of the domain. That's this one. And then we go all the way over to 1/2, 2. So it's this interval union with the interval 1/2, 2. That's the domain of the extended basic exponential function. Now the range is, well, we got y values that go from 1/2 down to -2. So listing the range, we would say, well, it will consist of all x values from -2 to -1/2. So that would be from here down to here. And all the values from 1/2 up to 2, which correspond to the y values on this purple curve. There's our extended basic exponential function. Now if we go to the complete extended basic reciprocal function, I hope I haven't been calling that exponential all along, but reciprocal function. So if we extend the function, well, as x values get bigger in the positive direction, 1 over x gets smaller. If x is 1,000, 1 over x is 1 over 1,000. It gets really small. It gets as close as you wish to 0. It doesn't get there all that fast still. We have an asymptote. Asymptotic to the positive x-axis. And on the negative side, we have the same values, except because of the negative, they'll all be negative, and it's asymptotic the negative x-axis. And also, if we keep letting x get smaller and smaller, like we went to 1/10, the reciprocal of 1/10 is 10, so this thing would be 10 units high. It's past the ceiling, I can't get there. Okay, so I just indicate that this thing goes up, continues getting steeper. It's asymptotic to the positive y-axis, and the similar thing happens here. If you were at negative 1/10, you'd have to go down to negative 10, which is down about where the floor is. So it's asymptotic to the negative y-axis. So the complete basic reciprocal function has a domain, consists of all numbers except 0. We can take the reciprocal of any number except 0. Well, the domain splits at 0, which we can have seen because of the extended function and because of the way division by 0 is undefined. The domain would then consist of all real numbers. You go as far as you want. You can approach infinity along the negative x-axis, and you can still take reciprocals. You get really small negative numbers, but you can do it. Okay, negative infinity, 0. All the way from negative infinity to 0, we've got to stop at 0. And one of these days I'll learn to be more attentive. I don't think so. Okay, I'm using the wrong notation here. Of course, the domain is a set. The set braces that I wrote down don't mean the same thing as parentheses as they're used for interval notation. Okay, anyhow, so the domain's negative infinity to 0, union 0 to infinity. The range, again, if x gets big enough, you can get as close to 0 as you want, but you can't hit 0. And on the negative side, you get as close to 0 as you want, but you can't hit 0. So, the range goes from negative infinity to 0, and then from 0 over here to infinity. Negative infinity down there up to 0, but not including 0. Positive infinity here down to 0, but not including 0 over here. There's your basic reciprocal function.